Okay, so last time we talked about global wind patterns and how we end up with those big system global winds, like the trade winds, the westerlies, the polar easterlies. Today we're going to talk more about pressure systems and local wind patterns. So think of it as like your daily weather, your daily wind patterns, because we live under one region. So we live under the westerlies. So what's happening, because we do have wind and we do have weather, what's happening on this local, more regional level? So regional pressure changes. Within each global wind band are regional pressure changes. And we've talked a little bit or touched upon some of these things already. We've talked about temperature. So temperature is seasonal temperature. You can also talk about like even the difference between like Florida and Maine has a much different temperature. Albedo, which is the kind of the reflectivity in a different region. So how it is here in New Hampshire in the winter versus the summer. That changes the albedo. And land surface versus water. So how much water, like are you near a coast or are you more inland? So these regional pressure differences create pressure systems that move across the continent, generating local weather systems. They're transported by the jet stream, which is a fast-flowing narrow current found in the atmosphere. The jet stream is typically in the stratosphere, and it kind of helps push all of those regional weather systems across the United States. So let's take a moment and just talk about the jet stream in particular. So the jet stream is created when polar air from the north, so think Canada, even parts of New Hampshire, the Great Lakes, meets more tropical air from the south. So Florida, Texas, Louisiana, those warmer areas. This creates a large temperature difference and therefore a strong pressure gradient difference. The pressure difference generates a zone of strong wind. Because remember, when warm air meets cold air, it changes the pressure, which pressure changes causes wind, and it's known as the jet stream. These winds can travel at velocities of 200 to 250 miles per hour, so the jet stream is very fast moving. Throughout the year, the jet stream shifts due to the temperature changes. So in the summer, the jet stream is the least pronounced because the temperature in New Hampshire and the temperature in Florida are more similar to each other. Even the temperature in Canada is more similar to what you might feel in Florida. So the jet stream tends to be either higher, up further towards the north, northern Canada, and it also tends to be a little bit slower. Whereas in the winter months, where it's really warm in Florida and really cold here in New England, you end up with a higher jet stream speed that moves across the country. And that moves a lot of our storm systems towards us. Either the jet stream can cause us to have like storm after storm after storm, or like it did last year, we get no storms from it at all because the jet stream doesn't fall over us. So, for example, if there were storms here following this track, you wouldn't necessarily feel them in New Hampshire because they would follow the jet stream. Okay, so when you guys have watched the news, you probably have noticed on weather maps that they show big H's and big L's, and they talk about areas of high pressure for the weekend or areas of low pressure. And from a couple of PowerPoints ago, I just want you to remember that high pressure is where air is sinking, so clouds can't form because the air is coming down, whereas in areas of low pressure, air is rising. So as air rises, water vapor gets into the upper atmosphere, condenses into clouds, and you can have precipitation. So wind that follows a pattern of movement around highs and lows, just like it follows a pattern of movement in a global scale. So wind tends to blow outward in a high and clockwise. And then in a low, it tends to blow counterclockwise and inward. For now, I just want you to know that we are going to do an activity later in which you will actually model those motions and why that happens. So regionally, differences in pressure, wind speed, and direction are based upon differences in temperature and pressure trends. So when they're trying to figure out where the center of a low is or a center of a high, so example for here in this map, they're like, hey, how do we know where the center is? They map areas of similar pressure along curved lines. They're known as isobars. So if we figure out where every place is that has 1,000 millibars of pressure, we connect those, and you'll notice they connect in like concentric circles. Once you figure out where the lowest one is, you can figure out where the lowest pressure is, kind of where the center of that storm would be. Where the lines are closer together tend to tell you that there'll be a higher wind speed, and where they're further apart, there'll be a lower wind speed. The reason for that is here the pressure is changing a lot more rapidly in a short amount of space. Here the pressure is changing less rapidly in a bigger amount of space. In the same respect, we can do the same thing with temperature. So this is known as an isotherm, like thermometer. So here we look at every place that has a temperature between 80 and 85. So we make a mark with all the 80s, and we make a mark with all the 85s, and then in here is everything between 80 and 85. So we know where the warmer temperatures are and where the colder temperatures are. This will also give us an indication of where the jet stream is, because it's a meeting of cold air versus warm air. So if I was to predict, I would say that the jet stream kind of comes up this way, pulls down this way, and then kind of comes out this way, because it always follows hot air versus cold air. So you end up seeing what they call a trough of the jet stream. Okay, so we've talked about global wind patterns, so the big picture. Then we've taken it down and we've looked at kind of regional. So what happens, how do we get weather patterns across the westerlies? Now we're going to take it down even smaller to just thermal circulation patterns. So land breezes and sea breezes, and then the next slide we'll talk about mountain and valley breezes. So if you've ever been at the beach, which I'm assuming many of you have, you'll notice that during the day, the land heats faster than water. So this generates a low pressure system over the land and a high pressure system over the water, because the land is hot, so the air rises, the sea is cool, so the air sinks. Wind always moves from high to low, so during the day, you get a sea breeze. And that's why we like to be at the beach on a very hot summer day, because you feel that nice cool breeze coming off the ocean. Now, if you've ever been to the beach at night and walked along the sand, you'll know that the water cools more slowly than the land. All of a sudden, the sand is really cold to your feet, but the water doesn't really feel like it's changed temperature. This creates a land breeze at night. So now, the high pressure is over the land because the sand is colder. The sea, in this case, is the same temperature, but it's warmer than the land. So it becomes an area of low pressure, and you end up with a land breeze where air comes out from the land, goes towards the ocean. Remember, we always name a wind based on where it originates. So in this case, during the day, it's a sea breeze here because it's coming from the sea onto land. Here, it's a land breeze because it's originating on the land, going out to sea. Okay, the last thermal circulation pattern is a mountain and valley breeze. So during the day, the heating of the high terrain, so think of like the rocks, if it's all rock face, that becomes an area of low pressure because the rocks here are heating. Whereas in the valley, it tends to be a little bit cooler, so you end up with a valley breeze. So the air heats, rises, and you end up with a valley breeze. At night, the slopes cool really quickly, but the valley tends to be a little bit warmer. So you end up what we call a mountain breeze because the air comes from like the top of the mountains down into the valley. Those are the circulation patterns and kind of jet stream stuff that we're going to talk about. We're going to do some more activities in class. So just make sure you have your questions ready, and I'll see you tomorrow.